Takes too long, I should just start. And you should be able to hear me just fine, hopefully. Yeah. Yeah, it's been a while. It's been a while. So I guess yeah. It's been a while since I streamed. I've been busy. It's been 2 weeks. 2 whole weeks. Hopefully today we're gonna, well, stream, I guess. Let's just wait for the flake to build. Hi, just Kavina. Your first day, which is rare. Rarely somebody except Nigel can claim first. But I guess you got lucky. Was this? Yeah, it's been a while. It's been 2 weeks. It's been 2 whole weeks. Well, I've been busy. I've been doing stuff. I've been preparing for stuff. Also, I've got this thing. This. Oh my god, that's mirrored. This is well, a tiny piece of tech I manufactured myself, which allows me to see time and hopefully more stuff than just seeing time. For example, watch YouTube. Yeah, it's gonna be hard to implement, but sure. Yes, I mean a clock. Watch. It's not just a mobile. I mean, like, this thing has Wi-Fi and Bluetooth and a screen, and it should be enough for me to fetch YouTube videos. But I mean, YouTube doesn't have their protocol public. There is YouTube GL, so a downloader, which I guess I can reverse engineer or just take a look at source code and hopefully see yeah, how it's done, and hopefully get YouTube playing on this, which, I mean, it's just a clock. It mainly was a clock. But yeah, I'm still in the process of developing it. Maybe I should make a YouTube video about it, but no, it's hard. It was my dream project, to be honest. Anyway, what's this? Okay, hold on. That's out of copyright free zone. Okay, so let's get paging, I guess. Paging. I barely remember anything because yeah, it's been 2 weeks. Paging. Where's the memory address space here? So yeah, we're yet to implement this function, which allows unmapping pages, and I guess that's fine. That's good enough for a pull request. So unmap a region of memory from the address space and mark it as free. That's it. That's the docs. Now, this is a trade, so there's nested page table which is in implementation. Yeah, not free. To do. Yet to do this. Also, there's bigger pages. We need bigger pages. Pages, oh my god. So yeah. Should I somehow add an iterator here? Later. I can do it later, but unmapping can't wait. So here I need to somehow go through this. Page size, I guess let's add a max. Okay, so we address line up to max. So let's start equals. Let's just do. I'm not quite sure how to do this. Size line down max, and I don't mean max, I mean page size. Page size max. No. How do we iterate properly? If I needed something like recursive. Because there's a so there are large pages and small pages, and I need to iterate through. So I need to check all pages. Okay, let's do start end, and let's do a line down here and line up here. For page in start through end, I guess. Start to end inclusive. Well, actually, so I need to. Yes, so I need to do this. Kind of do this. Hold on, that's not right. This excludes the last address. This is the address I should not visit. Yeah, that's right. I should just do a regular range. View size. As view size. And as view size. Yeah, so if the page equals word address from, well, actually, so I divide this by self page size max. I'm not sure how to do this. Line down, the lines address downwards. I need to like divide it. I need to step. Actually, I can do this. I can just do step. It's Rust. It's nice. Step by. self page size max as underscore, or actually like into does it take sticks view size? Okay, so page. Now if page is hi Nigel, welcome in. It's been a while, right? So if page is also I don't need parentheses here. C++ has been impacting me last week or so, and this has been impacting me a lot. So I guess I will put a bit too many parentheses today. Okay, so if page is outside of a range, or like partial included, so page is less than virtual address, then I'll need to split it up. As if page is greater than virtual address plus size, then I'll need to split it up. So if it is VR address plus size, then well, I shouldn't be including it in the first place. But it won't be equal, so it will be greater than. So this is wait, no, this is not right. If page plus self each size. No, I'm not looking at any nodes. I'm just looking at the screen, and maybe I'm looking somewhere like random point. Why is your name so empty? Oh, why is streamer body not showing me pages? Deep focus. It's not focus. I'm not focusing. Well, maybe I am. Into. So if this is greater than and because if it matches, we don't need any special anything special. And here I need to somehow unmap a page of the size. How do I do this? What do we have here? Top level, map a lock, map page, get entry. So I guess I should do get entry. Call self top level get entry. Actually, this should actually be in the trade, in the page, in the level. So I put it here. And then here I just call self top level unmap free virtual address size. So then I iterate through, well, okay, now that's better. Now here I can just do the self page size. And how do I, because self might not have page size. And let's do region size. That size of page table of this layer. Page size, but works if but returns the memory region page table manages sub-level page table managers if page can't be mapped here. Confusing, right? Bad documentation, but I don't know how to do better. Okay, so page size. Now I'm gonna do default implementation. This should return you size and self region size. Try into. Okay, this should be the implementation. The default one, because this should have on page size straight. Try from your side, right? Now. And page table. Yeah, memory address. Do I need it? Should probably. No, self region size. So self region size should exist. Self region size. So I go through regions. And then I go through pages, self region size. So I go through each page I touch, all this region touches, and then entry self get entry virtual address page. Now, if page is partially mapped, here, if page is to the left of the virtual address. So if the start of the page is to the left of the region I want to unmap, which means I'm unmapping the right part of this page or whatever, page or page table or segment or region. So I need to go to I mean, kind of a compiler should probably inline it, because x86 paging address space, yeah, here. So page table level should just return this expression. So I don't know. So region size I can just now turn use size here. Launch left self 1. So it should be cheap to compute, but like yeah, maybe. And I did do it not the right way. Oh, region size, because I'm forgetting Helix shortcuts. Page entry. Okay, so match entry. Let's match the entry. Oh, and entry. Okay, so here, level and page. Like this kind of error handling, by the way, it might not be the best way here, because imagine I just unmapped half of the pages and then error occurs, and then I come out with an error and the address space is just messed up. But I mean, what else can I do? I can't really revert it, because it would be too much. And yeah, if error occurs, it probably would be early. Hyphos unleashed. welcome in. It's been 2 weeks again. I've been doing stuff. I've been designing and making this thing. 2 custom PCBs, by the way. Fire. Oh, I was like, what does this regime do? I forgot. Oh my god. Now you have fire, I guess. See, this thing has 2 PCBs that are manufactured at home using photoresist. So this one and this one. And yeah, it's right now it's a clock, but hopefully it will be able to play YouTube as well. And also right now I'm discharging the battery to see how my percentage works. It's mirrored, you can't really see. Hydrate, thank you. But yeah, this is a cool device. I need to figure out how to make a case for it so that I can attach it. When will Satan outsell? Oh my god, outsell. I read it as outshell. And I was like, what does this mean? I don't know, ask Jax. I'm just a developer. I know Satan's gonna be able to run applications soon, considering I'm gonna stream more often and I'm gonna spend time on it actually. Well, actually, okay, so by the start of the summer, it should probably be able to run applications or like programs. Because I mean, start of the summer is a long way away, and we should really be able to get it working sooner. But Rust API. I mean, I guess you can say Linux has Rust API. I guess. I mean, like, what do you mean by that? Also, I'm using the combination of words I mean too often. So yeah, about a lot of this stuff you should probably be asking Jax, because it's not my operating system, even though I'm writing a lot of code for it. Physical address flags. See, the way so Jax said that he's all in for file system abstraction, and yeah, well, we have syscalls, we have system calls, so just list some standard system calls for file system access, and that's it. That's the API, and you don't need it to be bound to a language, because like, yeah, that's it. Obviously, Rust standard library must, Rust must have a target to build for it, because, I mean, if the operating system has Rust in it, so if the kernel has Rust in it, you should probably be able to build Rust apps for it. And C, of course, as well, which is just a few header files, and I don't know, maybe some C files. What the kernel does, how do you explain it? What a kernel does. Kernel. It's like, yeah, you've got those images. Hold on. Something like this. Well, that's basically it. So, what kernel does normally is that it boots up by a bootloader, it gets loaded by a bootloader, and then bootloader jumps to it, and then like kernel starts running. It initializes some stuff to start other stuff. Well, the kernel initializes, and then it starts an init process, which is just a program that initializes stuff, I don't know, runs more programs, etc. Maybe loads drivers. Maybe kernel has drivers in it, which depends on monolithic kernels, hybrid kernels, etc. Satan doesn't have an init process yet. Satan can't even run apps yet. But yeah. What's Linux's init process? May I ask you? What are you gonna answer if I ask you what init process does Linux use? And I can first I'm almost sure you won't answer correctly. Okay, so let me check flags. Contains. Contains present. Okay, so if flags contains present, turn and mapping. Okay, so error of mapping error. Use S6. What's S6? I'm pretty sure that's not what you're talking about. Scarnet small supervision suite. Skilibs S6. And init process, okay. But I just don't know why I scan it. Okay, so multiple init processes. Well, Linux kernel doesn't just have multiple init processes. Actually, Linux kernel has a single init process which runs as PID1, and I'm pretty sure that's always the case. But which one? The most popular is systemd. Right? Right? Is it right? Well, it's wrong because Android init system. Android is probably more popular than Linux than just GNU/Linux, so Android's init system is probably more popular. I mean, more people run it because more people use Android. And Android's init system is just starting init.rc files, which are a simple init language, and ex void. I'm not sure about void init system, but yeah, I was expecting you to say systemd or I don't know, run what was it, system5 or wait, sysv init. So yeah, there are many init systems, sysv init, and systemd is like run it. Yeah, for example, systemd is controversial, people say. But yeah, so Linux doesn't have a single init system, and in fact I actually have written one from scratch for an Android phone for like fun. Android tiny rootfs init.c here. I have booted this on my, well, not really on my phone, on a Redmi. Well, it is on GitHub. And why is it all commented out? Oh, that's because we had some problems. Okay, let's not talk about that. Let's open actually a GitHub version. Git github.com. I don't know this. Readme. What? Tiny init system to use with Android kernel. Yeah, this was my last keys. Before that is a Helix init, a Helix game of life. Then a minimal kitty graphics protocol example, which was like prints a tiny orange image. Funny enough, for some reason this orange was called orange in a bus .png on my file system. I just found it. I remember I drew it like a long time ago. Then we have HTTP ref shell, another HTTP ref shell but in Python. Oh wait, that's, oh yeah, that's client sh and client py. That's two different probably. Also, why is this secret? Huh? I don't know. Oh, random heavily parallelized Rust renderer. It's like rendering stuff. Template flakes. Oh, that's... I'm gonna leave this one out. I was writing a Rise Decay wrapper. SD in Rust, relief camera. Anyway, so the last thing I did, my last gist right now. Here it is. So a tiny init system which, in combination with the original kernel, can be used to build functional GNU/Linux system. So well, this is simple, cause so yeah, this is a basic init system for Android devices, and yeah, I have Xiaomi, Redmi setup here, but I think this actually doesn't matter. You can put anything here, and ID vendor and ID product. I think you can also find it on Google. Then iSerial. This is how I know that my init system worked. 0, 1, 2, 3, 4, etc. So yeah, what init system does is it makes dev/dev/proc/sys. Well, actually no, /dev is not made by init system. Wait, no, what? Dev temporary fs? Huh? Okay, so I guess dev is made by an init system. Then we mount proc and sys. Then here is some Android USB setup stuff, which creates a serial gadget and more stuff. I symlink it to /dev/console for some reason. Then I set LD library path to /lib and /usr/lib and /sbin. And I had my busybox built here. And then path as well. And then I execute /sbin/sh, which, because I have dap2 here, well, it's so std in and std out are mirrored with serial gadget, and so I run shell, and so I can do it with serial gadget. So yeah, compile it using this get toolchain. What is this? Oh, I think this is like the first toolchain. For some reason 2022 version. I don't know why I picked it, but I'm pretty sure any toolchain worked fine. Repack boot image or TWRP recovery. I actually have repacked TWRP recovery to use my init system. Profit. Why does it end with profit? I don't know. This doesn't even have a license. But I mean, should I license it? Something like well, Creative Commons. I can't license code as Creative Commons. I mean, I can CC0 or what are the public domain licenses? Should I add a license file here? Because by default it should be all rights reserved. License public domain code licenses. I normally use CC0, I'm pretty sure. No. I don't know. Should I just do CC0? Or I have no idea what this word means. Why is it late into English? English to, I don't know, Russian. Releasing to the public domain. Well, I guess CC0 is fine. Creative Commons generator. chooser beta. So I need Creative Commons 0. I'm pretty sure it's fine if I license it actually, because I'm not sure. Well, you know, I guess I'm gonna leave it. Because this piece of code is so tiny, it might be like licensed somewhere else. Anyway, this was a sidetrack for how 40 minutes already. That's insane. Anyway, so mapping error. Unmapping partial. Should do virtual address. Yeah, I guess. Actually, yeah, this exists already. Unmapping part of large page. This requires a physical address. So I guess p address. If it's a level. Okay, so if I should probably like merge those two. So if this is the level, I'm gonna do level on map free. And how do I? So I have this level. Can I just pass the address and size? To read through all the pages. Okay, not really. So I will need to clamp it. If page is less than the address, then I need to clamp size. So the address and page plus region size here plus region size, subtract the address. Else I can do the same thing, but instead I do so I start with page and end with plus size, subtract page. Should be right. Also type system suggests it's right because virtual address add usize subtract virtual address makes sense type wise. Anyway, here I'm just gonna copy this, paste it here, and if it's a level, then I'm gonna unmap it. So page and region size regardless. Else, if it's a page, I need to unmap the page. If it's present, then self-set entry virtual address entry. Virtual address is gonna be page. Entry is gonna be How do I do page table entry of self? Oops. Page table entry. Page table entry. Level page. So page of. I guess I could do null. And then declare null here. Oh, it's in an page table entry level, where level is a nested page table const null self. What do you mean? It's not satisfied. Wait, nested page table level. Nested. So self page of physical address. New size 0, I guess, and mapping flags empty. Yeah, it's const, it's fine. Now, this should work in theory. So unmap free, which should unmap the thing. And yeah, we will still have to add cloning and possibly bigger pages here, but I guess fine. Now let's go for testing. Page table entry here. No. Probably here. We have setup paging. We set up enable PSC. Oh yeah, also the zones. I forgot about zones. Okay, so here we do. Here's the testing stuff. Mapped road test page mapping, then unmap free. Size is usize. Let's just do. Wait. Just thinking what is 2 to the what 12th power was. Yes, we unmap, then testing page unmapping. You should see a segfault, and then I'm gonna do create print line. Okay, let's see if I still remember stuff. Page size. I need max. Wait, I don't need max. Hold on. Let me remove the max from here. Testing page when unmapping, you should see a segfault, page fault. Let's go. And not segfault, obviously, a page fault. Because segmentation is not a thing here. Because I had some segfaults. And unwrap this for testing purposes. Page fault. Now let's address some warnings, which are just good. cargo clippy. Okay, there's a lot of stuff. Address space. Memory address can be removed. Interrupt stack frame is never constructed. That's fine. That's fine. That's fine. In interrupts and in x86 mode. Okay, in x86 mode is fine. In interrupts, where's the loop? Oh, that's interrupt handler. It's fine. Considering a default for zoned body. Yeah. Default implementation from new function. Impl default. Empty loop. So yeah, default. Then this returns use a customer type instead. Line 36. That zone returns a result of nothing and nothing. All size of is not aligned. Wait, let's return an option. Cause 3 and 3 probably because of allocator. Yes. So I guess I should return an option instead. I mean, I can't really, because like allocator stuff. Is there an allocation fail there? Alloc. Well, use core alloc. Alloc error. I think I should. Well, actually, well, let's import it. And this is just a unit struct. Okay, this is nice. This is nice to have, actually. This is really nice to have. Clear git git add git commit page unmapping. Hold on. Actually, unmap. We do unmap, but we don't free. I absolutely forgot about this. Oh no. It's actually what do again? X11 fails. You called X init threads. This is not your fault. Again. Okay, sure. At least now I'm catching this. Like half an hour without an overlay, without knowing that people write in chat. No. Mod res and paging. So here I should somehow check the free kernel space. Mapalog. Where's the page allocator dot allocator. There should be like get free space or something. Well, I should implement it. Zoned body. F and free. Is this by the way, wait, this is not recursive, is it? Interestingly enough. Like how? Okay, so function. Space. Or like total memory. Transient size. For zone in self zones. Read iter. This obviously takes self zone size. Well, actually, I should probably like hold so accumulator and zone size. So we're actually accumulator and zone size. Returns total amount of memory available managed by the allocator. Get free use self-free memory. We're gonna implement. Why is it still? Oh, wait, this should be public. Also, this should probably be public. So I'll open free. And use how do I can I do like total memory subtract self-free memory. Alright, self allocated memory. Let's do it instead. Allocated memory. I don't actually know if zone provides anything like that. Zone dot body by whatever. Hold on, this is by dialog. I'm not even sure what creates this is look free body allocator. Yes, this create is not well documented. Free node free. Okay, so this does not store the amount of free space allocated. So I guess I'm gonna do it myself. Allocated 0. Allocated add size, and this is not right, so we're gonna swap this for size atomic use size. Size. I wonder if there's atomic non-zero use size. I'll just import it and merge. atomic use size new 0. Now we're gonna add size, fetch add size, ordering. Okay, so I hate this. I absolutely hate those, but so sequentially consistent. Okay, so acquire release is good enough. So if we add something, then we check it. Or sequentially consistent. Should we do acquire release or sequentially consistent? I absolutely hate orderings. No, I don't hate Rust, I hate orderings. C++ has exactly the same orderings. But it's like, look, corresponds to this in C++ 20, corresponds to this in C++ 20. But I still don't understand this. Theme change, Zimber, theme, then burr. Oh my god. Can't spell, I can't type. I can't talk. Frames bad, oh no. Not again. Network. Okay, network's fine.
Can you read chat, please?
I see chat. Okay, again. This again. Okay, hold on. Let's try this. Streaming from Wi-Fi is hard. Now it should be better. Okay. Seems fine. So yeah, sequentially consistent. There's additional guarantee that all threads see all sequentially consistent operations in the same order. Let's just do sequentially consistent, I don't care. Okay, again, this problem. How do I tell which file is open? I mean, I guess this one, because it's darker than the others, but why is this part of the title bar dark? Like, is this the case for any theme? We just, what's the default theme? So I take two files. No, it's not the case here. Default. It's not the case for default, even though it's not really noticeable, but it's still like is. So, but I think it is better than here, and most other themes. Anyway, okay, so we add it, and let's just do sequentially consistent because I'm lazy. Your theme thinks that won't, I guess. Okay, GitHub links. I don't remember how themes look. Didn't burn better. This is a theme. Okay, so where do I put it? Overrides, editions, overrides, editions, huh? Okay, so okay, good. Where do I put it? I guess in config helix. Where do I put it? Themes, or do I put it in downloads or something? No. Okay, so I should have probably saved. Okay, it is here. Yeah, this does look better to me. Really. I can see it is darker. No need to reload config. I mean, I don't know. I did reload. Okay, so we fetch sub. The size. What does it return? Nothing. Let's just hope it works. We'll hope it is good. Because this might introduce bugs. But I mean, just analytics or something should be fine. Self zone, 3D zone, allocated read. How do you read? Get, mute, no. Value. How do you read it? Or is it fetch? Fetch. How do you get the value of atomic size? Wait, can I just... I don't know. Atomic int... Atomic size docs. By the way, it's 75% here. I don't know if you can see it. See, I'm running a discharge test. Well, it says 75%. I'm not sure if it is 75%. Okay, so atomic size from pointer get mute, from mute get mute slice into inner load. Okay, it's called load. Makes sense, you know. Ordering sequentially consistent. Now let's do create print line total memory in the allocator currently. Total memory. Okay, now. Oops, I did just a regular clone. It's actually not that cold in here anymore. I thought I'd have to stream for like 30 minutes and then and then it's gonna become too cold and I'm gonna have to end. But no, I guess. I'm just gonna copy paste this after I mapped. And then after I unmapped. What? Oh no, not again. QEMU crashed. QEMU crashed. Why? Why does this happen to me? QEMU crashes. How do you debug stuff? What? On any tab background? What? Is it written in Rust? What? So where's build? Where's run here? Dguest errors, no reboot. Dguest errors, no reboot. My browser? My browser is just Brave. What's wrong with it? Oh, you mean? Oh, it is different every time. Oh, here it was. Here it is. Ah, where did I click it? I mean, I did click it, so I guess yeah. Okay, so QEMU debug crash. How do you debug QEMU crash? Okay, I don't know. There's capital D. That's probably not gonna help. Monitor, maybe. Double quotes. Apply fix. Wow, that is interesting. But no. Sorry. Can return 0 to 55. Other data should be written to standard out. Huh. Okay, let's change this to 1 instead. Never used. Yes, like that's like bash LSP. Where's QEMU system? Control I, which is tab? No, it's x86-64 because i386 is not supported. Sorry, I'm not doing paging again. I'm not falling into this thing. Okay, so monitor. Let's try monitor. Oh, it monitors keep. There's DCPU reset to ISOM CPU reset and remove the monitor. Triple fold. I guess I should be catching interrupts. Interrupt handler. What's a double fault interrupt? Interrupts. I mean exceptions. I need to handle double fault so that it doesn't go further. Hey. Okay, what's wrong? Huh? What? Okay, so it's from 0 to 31. So it's less than or equal to 1F. If interrupt equal to 0x1F, create print panic exception unhandled exception how do you do hex cons hash x Unresolved import. It's not great panic, it's just panic. And then also I'm gonna add a double fold. Double fold 0x8 08 double fold error code. Let me do error code. I'm just gonna print it as hex false. What's so if an exception happens and while processing this exception CPU catches an exception, double fold happens, which is an exception. And if something fails during double fold and an exception happens, CPU goes into triple fold, which is not handled by the OS anymore. It did not only fail one time, but 3 times in a row. That's not up to Rust, that's up to x86, which is a dumb architecture. Have I said that already? Error code, which is also gonna be hashx. And I'm gonna comment this out in order to see the exception. The double fold, make sure. With other languages succeed on the first time and fail in production. Okay, so this seems to not work. Also too many parentheses. Yeah, too many parentheses. Hold on. C++ is impacting me so badly. GPU reset. Okay, so triple fold. I mean, it might triple fold like in other conditions. There's d in. Let's do int. Service handling interrupt 8. Then an exception. So an exception 0xe happens, which is page fault. Huh? Then D, which is general protection fault. Which in turn wait, what? D, then double, then it says double fold, and then D again. Why does it fail? Why does it bypass my interrupt handler? That's the question I want to ask. Okay, let me do the panic. Because maybe it doesn't run the double fold, I don't know. It doesn't fail at all. So it goes page fold, then page fold to general protection fold, which should be should handle double fault. I don't know. I'm not sure how QEMU handles it. Which then goes to general protection fault again. How do you debug this? QEMU monitor STDIO. Maybe you're smarter than your compiler, but you're not smarter than Rust. Monitor STDIO. I wonder what this is. Give me monitor, help. Okay, what's the monitor? Log CPU on. You know your life days. Dash S. Okay, let's do dash S. So that it doesn't start early. Log CPU on. Huh? Okay, that doesn't help. Okay, diagnosing a VM crash. Frequent crashes or performance issues. Use specific login options like CPU reset int. The issue triggers the problem. So abnormal login check. QEMU debug log file. The file display memory, net device, monitor. There's the detailed log. Okay, let's do this. So let's add the detailed log and remove this. I don't know if it's gonna show anything useful, to be honest. Detailed. Well, yeah, it's empty. Okay, let's add what? There's D in awesome and int. Not only guest errors. It is comma separated. In some int. Okay, now reload this. Now this has some stuff. It has an exception. This has assembly. Hey. This has all the assembly. Okay, anyway, in assembly, okay, so this region of code. Call L. I guess jump page faulted for some reason. Okay, so I don't know why, honestly. Feels like it misses, I don't know, atomic handling routines for some reason. It fails in here. And probably even if I remove this, till I like roll back to the initial code. It's if I comment out allocated. I mean, maybe it doesn't fit, you know. Maybe it doesn't fit into the heap. Okay, let's try this. Oh, wait, I'm dumb. Undo. This and this. Because I didn't recompile it. I'm pretty sure. Okay, now that's better. Unhandled exception 0xt, which is a general protection fault. I still don't know what Dima is doing here. some kind of evil stuff. Yes. This is evil. It involves Satan, you're right. So much pain. It was so much. Total memory 9k. No, 90k actually. Mapped road, testing and mapping, page fault, error code, and then GP general protection fault, which is 0xt for some reason. What? Oh, and what? Oh wait, okay. It was capturing my keepers. 0xt, which is yeah, GPL or what? Error code 7660. Finish now, by now, or why another new project? It's not a new project. Like, it's been around since September, I'm pretty sure. Or when did we meet with Drax? And Orko is not nearly finished. And once I do paging, we'll switch back to Orko. You know me, yes. General protection fault. I'm thinking of those two projects intersecting at some point. This way. Okay, so where's the general? Okay, here. Segmenter. Privilege type, writing a 1 in a reverse reserved register field. Angster memory address with bits is not 47. 4-bit mode. Executing an instruction that requires memory operands to be aligned without proper alignment. Saved error code. The segment selector index. Otherwise 0. Okay, so it is segment related. Selector error code. TBL E. What's E? Externally to the processor. This is not right. 7660. Okay, so yeah, that's right. Now, come on. Now, so huh? This thing is slow. This class Rust is better. Rust is always better. Okay, then TBL 2 bits. 0, 0. The first byte is, well, the first 4 bits are 0. So I can choose this right by 4. Hex 766. Choose the index. So Jai gets released. Uh, 766. Jai sounds nice to me. Okay, so let's go to, I guess, bootstrap assembly. Why is it index 766? Frames, but okay, no. Not again. Please just work. Actually, I have no idea why it fails. But I guess it fails. Okay, so why did it fail? It even fails on total memory. Well, actually, it kinda doesn't. Interrupts. So then it goes to general protection fault in the interrupt. Oh, cause return. Hold on. Halt. This is how you spell halt. Cause yeah, it wasn't supposed to return after that. Really. Halt. Okay. That's better. Now let me, I guess, add in those one by one. That should be 0. But instead it just terminates for no reason. So I can't load a value for some reason. Let's do ordering relaxed. Still fails. Why? Maybe it overflows. Probably no. Can I just do the zone size? Is it gonna fail the same way? Probably not. Yeah, it won't fail the same way. Obviously. So for some reason reading from anatomic fails. Great. Look, API atomics or spin atomic. I mean, I can actually do create sync RW local view size. Just for testing purposes. And I don't actually have to spell the whole path here, because it doesn't put it up here. Alright. Equal size. Oh, this isn't free. This is in alloc. And now this is in evaluation part. Frames. Oh my god, why? Why am I losing frames? Why am I dropping frames? I need to pick them off. Pick them back up. Stop dropping them. Also, did it fail again? Huh? What? No, why is this fails? Why does this fail? Undefined behavior again? Like, why? Why are you UB? Should we roll it back properly? Sequentially consistent, okay. Oops. Allocated memory returns the amount. Allocated memory. Pretty simple. So I don't know why it fails. No reason. Also, it's probably too dark. Hold on. This should be better. Is it? No. Try situation is insane. What can I do to debug this? Oh, by the way, I can actually, you know, build and then do QEMU with detailed log and stuff. Okay, same thing. Page fault switches to general protection fault, and here double fault switch to general protection fault again, which sounds honestly like interrupt handler is broken. Chemic with for some reason. Wait, I have a loop here. An infinite loop here. So it shouldn't. I don't know why. Timer scan codes. Can like, yeah, can I like do this? Like set for timer. I must do timer. Yes, timer is here. Like everything else doesn't matter. Okay, so it did work now. For some reason, when I do page fault, it fails to handle it properly. Maybe printing stuff issue. You know what it might be? You know what it might be? It might be a bit insane. If I do something like this and it fails, and I know why. Oh wait, no, hold on. Hold on, that's not right. See page fault. So somehow page fault fails. Okay, if I do this, maybe it's formatting issue. We just remove error code from here. Okay, so printing error code fails. In the format, properly formatting it. I don't know why though. Like here it works. I just do :# 032b, which is 32 bits of leading zeros binary. Yeah, now it fails for whatever reason. If I do 12, just a random number. Still fails. If I remove them, if I remove the hash, this is like 0x or 0b in this case. It still fails. If I remove the b, the binary, okay, so it can't print in binary for some reason. Why? Like why? Clone B. Weird. I feel like it's like, I don't know, not enough RAM, not enough stack. Can I print it in hex, by the way? Not in binary. I can print it in hex. Interesting. So stack is on bootstrap. We have bootstrap stack and CSS stack, which is the thing. Let's double that, I don't know. Stack is readable and writable. What's this hex? This was hex. Back to binary. 32 kilobytes of stack. And it still fails. Okay, so this is probably not a stack problem. Maybe allocator. I mean, I shouldn't really worry about allocator. Main.res. Not main. Where's the allocator in moderate and x86? You have this 10 times the size of the allocator. Still fails, huh? Well, actually not 10 times, the 16 but 16 times. Still, maybe early logger. Writer, set color, new line, clear row. Right. If I comment this out, we won't see anything, but we will be able to tell if it fails. Yeah, it doesn't seem to fail anymore. So it is a writing issue. Why? Character new ch self color. Maybe character is like wrong. Unicode. Do dots instead. No, it fails. Okay, so writing random stuff here doesn't help. I don't know, maybe VGA overflows or something. Schools and science, right. If I do 0 instead. No, that doesn't help. You know, like if removing this line optimizes something out. Build cargo build. Just disable all optimizations. Cargo disable all optimization. Whatever. Profile cargo book. Like the ones that might impact it. I mean, it isn't optimized. I don't know why. Why does it fail? Maybe 0 instead of color. I don't know. Just random at this point. Yeah, of course, not gonna help. Commenting this out does help for some reason. Feels like a quote sizer here or something. Buffer is just a mutable region. And it is mutext. Why? Why is it not working? Why does it fail? 0, 0. Probably will not help. Okay, it does help. Interestingly enough. We bring back self-call. Won't work. If I do this, it's like just literally magic. Literally UB in throw form. Yeah, exactly. Why? Why does this work for some reason? Maybe I'm accessing something. What's with J width 80? Okay, I did go a little over. Does it 79? Okay, 79 doesn't work. 50. Okay, 50 does. 51. What am I doing? I'm just writing to random pieces of memory. Row 70, not 79. Okay, 70 doesn't work. 69. Doesn't. 60. Yes. 60 does. 65. Binary search. From this point onwards. Well, no, I'm not gonna do it. 63. $63 does work. 64. Doesn't. What? Okay, so this is what? 6 bits? It's more than 6 bits and it fails. So if I do call percentage sign, so division reminder 64. Which self call, obviously. Fails for whatever reason. Huh. It's like no reason it will fail. If I switch to line 1, will this work? Probably fail, or I don't know. Yeah, it failed. I do 1 0. Why? Why is it so wrong? If I do self call reminder to Reminder 1 is probably gonna optimize this out. Yeah. No, it didn't. For some reason. Well, maybe it panics because... well, no, it can't panic. Why? Why? No reason this won't work. For some reason accessing self-call here fails. Okay, this did work for some reason. Why? What if I do CH here? Yeah, it fails. To be expected, I guess. Frames bad again. And is there... No, what else can I do except for staring at them and hoping it gets better? I don't know. I don't even know what to do with frames dropping. Nor I know what to do with this, which for some reason fails. Like it started failing when I added some code. It does feel like not enough memory or something problem. I should actually, instead of all of this, I should actually kernel page table bootstrap, kernel offset, first page table in the higher half of the upper space. Okay, so where is it? Unlock. I was thinking about doing like large pages, but not sure. Maybe kernel doesn't fit, you know. What is this? One page table. This is one page. Yeah, this is one page table. Take kernel reserved and JB. What does JB mean? Jump quick reference. What is it called? JB. Oh, below. Jumper for both. Okay, let's do jumper for both instead. Again, I don't know what to do with them. They just drop. My internet is just bad. 104%. Okay, now just go and work all of a sudden. I'm saying this to my frames. JB E. I don't know. I don't know why. Compares this to kernel reserved end, and if it's less than or equal to, well, I mean, it should be just less than, probably. It's still like above. It should work, but it doesn't. I don't know why. What if I comment out new line? Well, most of the new line are seen. It does work. Why? Why does it? Probably because because like code size or something. Okay, what if I comment out a random piece of code? And actually like random piece of code that I'm pretty sure is not gonna mess everything up. I don't know, a piece of error handling. Debug cert. Okay, those two. In temporary page, is it gonna work then? Which like it does. Okay, so it is page size. It is like a code size problem. This is like so obscure. Imagine your code being so big that it messes something up, and this crashes. For some reason, my assembly checks did not check it somehow. I mean, I think I actually know why. I mean, okay, I don't. They should have caught it. Why? Why commenting out random pieces of code? Break stuff. Well, fix stuff. I mean, I guess I know why, but I guess why. I can guess why. Map the first page table. Okay, let's see. First page table in the higher half of the address space. Table bootstrap and kernel offset. Higher half. This should check if kernel fits. Like, what is it? Linker script, 32 bits. So we have this is a dot and then kernel reserved end. So I take one page table, exactly one. If I do 3 here, it's not gonna fit, right? Should probably check kernel size itself. No, it does. Huh? Why? Probably messed something up. Probably just messed something up. 3 dump. It's not disassemble. So read elf instead. Yeah, there are a lot of stuff. RG kernel. Grip kernel start. C01 105 whatever. Kernel reserved and absolute. C015. Maybe I'm mapping something wrong. Start address. So the kernel start physical and address is the data start physical, which is where's data start? Here's the data start. So we have code and then raw data. This is compute offset into page table. Kernel start, subtract kernel offset. So that's offset into page table. Makes sense. Shift right and then add. For whatever reason, I'm adding this. Oh wait, I'm adding the page table address to the offset, which makes sense. And we have flags, we map it, and then there's kernel end, and then there's kernel temporary page. Also, why is this not 4K? So kernel should fit. Okay, how do I read sections? Capital S. Boot address offset size 105.139. Data then. So data is have kernel end at C14 EC9. So it's 14F basically aligned, and then reserved, and it's gonna be one page later, which is 15. Okay, so 14E99. So if I add 013E and I add this is the right one. 109 39. This X 14E939 sounds right. Okay, so this is kernel indeed. So then we've got God sections, PLT sections, debug sections. Okay, debug location, debug look. What are those? Maybe I should have actually added those sections somewhere. Like there's God section. What's God? Global offset table or something? Seems dynamic linked functions? No. Got global variables, got PLT global function. What? Also, I feel like... Okay, yeah, we are again out of copyright. Inside of copyright zone. Where are we? For some reason, this is in the playlist. Why? Okay, suggest me music to play on stream. I have been playing Mario Galaxy. Maybe I should actually probably play like once at least to recall how it was. Okay, so I should loop this. And this is a different from what we had. I'm pretty sure this is the start menu music, by the way, because I have seen Super Mario Galaxy a little bit. I have watched first few seconds of a playthrough. No. Global offset table. Should I like put global offset table somewhere? Bare metal code section. Okay, so can I put it somewhere somehow? Something like this. So we've got got and then debug. Got asterisk that, and then debug asterisk like that. Comment. Pretty sure sim tab is fine. This linker script? No. This is linker script. We're in linker land right now. Do they run this? Won't work. No idea. Kernel too big. It says kernel too big now. Because if I read elf sections... So got is now inside of data. What? You have never heard of linker script? Linker script. So you know, how do I present this better? You know LDD or LD version. Okay, it's probably too big. So you know what a linker is? I mean, I'm pretty sure you know what a linker is if you're following a guy who builds compilers. Doesn't even say anything. Doesn't even say anything. So LD is a linker, and well, GCC has a linker embedded. Now, linker script is something you normally don't supply to a linker. But here in this case, I need to manage layout of memory. So I need to manage memory. I need to manage the layout. So I need to set a layout of memory myself. So like, when linker links stuff together, I also supply a linker script, so all of this to it. And it includes boot, which puts all bootstrap sections here, right after 1 megabyte. Then I add a kernel offset, and then I store all the code after the kernel offset. And yeah, stuff like that. Hold on. This feels too loud. Come on. I wanna see if it's quieter. It's really loading circles. What were those called? I forgot. And it doesn't even load. Come on. My internet's so bad today. So yeah, this is a linker script. And I guess I did put all the... everything. I wonder what comment section is. So got is global offset table, I guess. Which I don't know if they need to be read-only. Debug, I'm pretty sure debug can be read-only. And it is gonna say that kernel's too big. Probably yes. What if I comment out global offset table? Apparently I don't know Rust and how it works. Kernel too big is with debug. Okay, for just for the sake of... Wait, I can't really build it with release, can I? I mean, I can, I guess. Okay, so if I comment out the debug asserts. So I haven't considered... Yeah, I haven't considered all the sections. Yeah, it's still too big. Okay. Let me think. So we do need a second kernel page thingy. Okay, actually, let me actually do this. So here we enable page size extension, which I am gonna do in Bootstrap instead. Stop TSS, stop GDT. So we're gonna do enable PSE, then enable paging. Temporary register. More EAX. X or then where's percentage sign? EX. Move EX. Therefore, okay. Okay, so we enable PSE, page size extension. I don't know why it's 0x10, but sure. Then we enable paging. So then here I can, instead of like doing all those page table stuff, I'm just gonna store top level page table, kernel temporary page entry addresses, and yeah, it has some problems. Mainly the flags. So I should I do the whole kernel mutable or undo all of this? I changed my mind again. Let's just add a second page table. So Bootstrap. Let me. So before I do Bootstrap, it's moving to EAX. This value. Compare it with kernel G is gonna be kernel bootstrap and which I'm gonna add an extern for. I'm pretty sure this is after. Yeah, kernel starts after that. So bootstrap and kernel bootstrap too big. So here I'm gonna jump and copy that. Yeah. I'm not doing bootstrap. Where am I? Should I just write a quick Python script that's gonna generate all of this for me? Let's see in use Helix. What do you mean? I'm using Helix. Okay, so print C. F Oh wait, F strings don't work. Percentage C. Equals to IC. Multiplicers. No, I need numbers to increment. That's a problem. That's why my shell is Python. So CI hex. How do I hex a number? Actually, no, it's not like that. Move W dollar percentage C or x0400 space 0x percentage C. Sounds about right. I wonder what are those spaces. Oh, those are my new lines. Okay, so for example this, oh, and Bang, of course. Okay, oh wait, percentage C. It should be percentage X B800. So I add 0x B8 extra 3 zeros. Start with and multiply it by 2, obviously. I think I did this one manually. Coffee. I wonder if my bootstrap is too big indeed. I just want to see if this message is correct. Kernel too big now. Bootstrap is fine. Then let's make it too big, or let's make it too small. So let's do 1 megabyte, which is not enough for a bootstrap because bootstrap is located at 1 megabyte. So it should say bootstrap too big. No, it doesn't. Which is sad. Which means I messed something up probably. Because this is 4 megabytes, right? Actually, no. This is 4. Yeah, this is 4 megabytes. This is right. If I actually make it 0. Okay, so this is messed up. Wonder why it says kernel too big instead. Is kernel bootstrap actually kernel bootstrap end actually 0? I feel like no. Huh. So let me read elf. There's kernel bootstrap and 1. 104. 3, 4, 5. So this should have failed, but it didn't for some reason. Maybe it didn't recompile. I don't know. x86 mode. I'm just gonna edit one character so that it recompiles this file, which probably will not fix it. Yes, which is weird. And I am jumping to the right thing. Kernel bootstrap too big. Which is here. Which is the right thing. What if I actually swap those? I'm pretty sure it's not gonna help. Okay, so yeah, this is interesting. Now it doesn't activate kernel bootstrap too big for some reason. So check for bootstrap first. What if it changes to jump like unconditionally? No. Hi. Chandu 16. Well, for some reason assembly doesn't work the way I expected to. Other than that, it's probably good. A Rust kernel, which can be found at GitHub, Texelware Satan, but what I'm doing right now is on my fork, which is not even pushed. Side project from a compiler, I guess. I mean, side project. This is just another project. So two main projects on those streams are work on my compiler and the Satan, which is not mine, but it's a kernel I have put a lot of work into, and will probably continue be doing so. Okay, so why is this not working? Jump above. See if it's above. Well, it's not above. Huh. Like here it should work. Very shorten it. Huh, now it does. So this doesn't like weird. Weird. Kernel too big. This is weird. Read elf. So kernel bootstrap and is this number hex compared to 1 or 5 zeros. So this is indeed above. Okay, let's see what what assembly thinks it is. Kernel too big still. 8 bigger than 8. Okay, if it's bigger than 8, I'm pretty sure it's bigger than 4, which we've checked. No, we've checked. Okay, so it's bigger than 8. 80 actually. 80,000. Is it bigger than 90,000? It is bigger than 90,000, but less than... What? Shouldn't. Because if I read delf and see the symbol value, it is this. So this is wrong. Why? Lurk. Welcome back, Nigel. Okay, for some reason, I mean, right now it does kind of work since it's less than, but this is wrong. Also, what about kernel reserve 10 now? It's 47. How? That's a lot. By the way, well, okay, no. It's too early to go into linker script. Okay, so for some reason kernel bootstrap end is not what I expected to. Oh wait, it's missing a dollar sign. Oh my god, I keep doing this. Cause here it's fine, but here it's not. Oh my god, I'm reading from the address instead of using it. Okay, that's why I don't like AT&T syntax. Implicitly reading from an address is like, is just insane. Now that will work. Why? Why? Yes, this does. Okay, so kernel too big apparently. Let's now make it bigger. Push table to higher hub. First to so digit 2 each tables. It makes push the here half of the address space or into. Okay, so this is page table 1. This is gonna be page table 2. So the address of it. Maybe I could have incremented it. So add 4. Okay, now let's do EX. It's gonna be this, or obviously, and then move EBX into EBX. We're gonna move. I was not intending to do assembly today, but sure. Okay, so this is addresses, so I need to convert it to a value. And now how do I take this? I think then add to EAX. I add one page table, which is 4K, which is 1000 in hex, and then I add 2, or actually 4, to EBX, which is the entry. Now I should be able to compare. Where do I check the kernel to big? Kernel to big. So here I compare with 8 million now, and now I also need to Map. Kernel page tables higher half. I'm gonna do kernel table 1. Temporary page. So this is gonna be okay. I'm gonna do 2 separate field directives. Higher half. Invalid write at address whatever regional reason rejected. Okay, so this is interesting now. Will it work if I comment out some random debug stuff? Or I don't know. This part of a new line there of a new line function. I'm pretty sure this is not gonna help this time. Yeah. Okay, so we have invalid writes. Okay, before I call key setup, let me jump to kernel to big, so that I can see if it gets there. But it does invalid writes, which is well interesting. Stop temporary page. So in page tables, I add the offsets. Should be right. I do enable paging. Here I do memory mapping. Okay, so it still does invalid writes. Where's memory mapping function? Here it is. Add 4K to this. Okay, yeah. So here, memory maps. Oh, and address. Wait, it's cast stream recently. He was adding references. Let's go. References are great. References are important. Okay, so bootstrap. So this is a kernel self mapping. So we go from kernel start. Start 10. Put it in here and kernel end. It should be mapping just fine. Okay, so if I go first, immutable regions. It still does 4 invalid writes. At for some reasons weird address. Okay, so if I do this before I call memory map first time, maybe I forgot a $sign somewhere again. Okay, if I copy this value, 3, 54, 55, 56. Okay, so those are 4 continuous bytes. Oops, starting with F. Ignore case please. Okay, this did not find anything. I guess let's then debug further. Where I'm accessing something I should not be accessing, or writing something somewhere. Okay, this is already written. Okay, maybe I'm doing this in bootstrap mapping. Just get some water. No. Even earlier. Okay, so there are invalid. Oops. There are invalid writes here. So if I do it here, it should probably get rid of them. Maybe. Yes. So if I add 4 to EBX, it's gonna make a difference. It's gonna mess it up again. Yes, it is. That is interesting. Somehow, for some reason, this page is messed up. Like this entry. So this is what? This is one page table. So I divide kernel offset by page tables. Multiply it by 4 bytes. So this should give me what? An offset. Yeah, right. Kernel offset top level page table. Oh, makes sense. Why can't I add 4 to EBX? 4 bytes. I mean, I can try 8. Maybe it's gonna be an alignment issue. No. C3, so B53, C3. F0476 B53. And 4 EC now. Okay, this is different. This is really different. I don't know why though. Size 1. I'm not writing size 1. How do I move the word? To L is for long. Say bytes. It's still wrong. Why is this writing 4 bytes separately? One by one. Oh wait, I see why. Why does this happen to me so often? Did I mention I don't like AT&T? Okay, something happened and it crashed again. I saw 2 lines of text. Curzon. T-shirt. Curzon. Wow. That's interesting. Out of memory, huh? Error out of memory. Twice. I'm pretty sure that's in Bootstrap. Okay, maybe I shouldn't hold, instead create a loop here. Wait, is that out of memory? Okay, so yeah, it freezes, which is right. But now if I call key setup, where is anything? Okay, if I loop here, so we do hello Satan and then we freeze. Okay, yes, this works. And by the way, early logger, yes, so all fine. Now setup interrupts, which should be the second line that was printed. Yeah, IDT is set up. Now Page table. Paging setups. This is all my pain. And it doesn't work again. We comment all of this out. Will it work? More binary debugging, let's go. It won't. Interesting. Unused kernel address space. What? Okay, now it is used. Okay, if I loop. Now, I should probably check the crash reason. So it might be in the allocator. VDT setup. Oh, and it panicked. Yeah, that's right. That's my interrupt handling. Okay, so add zone. Will this work? Add zone does work. So this thing. What? If this like crashes right now, I don't know why. This would be weird. No, it doesn't. Huh? What? Okay, bullet print total memory. I'm just gonna debug line by line. Okay, it won't print total memory. Interesting. Which reads all zones. Okay, let me actually run QEMU with debugging stuff. So instead of in awesome, we're gonna do CPU reset. And it crashed in triple fold. Okay, so we've got what? Page fold, then another page fold, and then another page fold? Huh? What? Okay, this is interesting. If I loop here. Oops. So if I loop here, this should probably work. No, it didn't. Because I am checking for page folds. And this does triple page fold. Why? It's E. It's E, right? Yes, it is. It is a page fold. 3 times in a row. Without me catching that. Or at least that's what the thing tells me. Maybe actually it's 0e plus 0.08. So maybe it's x equals 26. Might be. Let's do FF instead. Well, obviously this panics. If I just loop, well, this won't help, will it? Okay, let's try looping here. Like timer interrupt. Yeah, this won't work. Okay, so for some reason this thing fails. Why? I don't know. Okay, so if I comment out this whatever, will this fail again or will it not? This will fail. Okay, so just commenting random stuff out doesn't help anymore. Sadly. What if I include got and read-only data? Just global of the table. Still crashes, huh? I don't know why. I don't know why. I don't know why. Okay, I guess let's debug. I don't know, line 110. Break src arch. Alright, Satan. No, hold on. Arch. Beijing. Wait, x86. Beijing mod rs line 110. No. This doesn't work. Interesting. Okay, let's do Satan H66. In what? Interrupts or instructions. But it's x86 paging. Alright, set up paging. Invalid read. Huh. Continue to breakpoint. Process exited. What? Oh, breakpoint instruction. Breakpoint interrupt. MU66 X6 X86. My 8 keys. Bad. Calls for debugging a bootloader. What I need. I don't remember which one. Kernel debugging. Interesting. That is interesting. But I remember there was a breakpoint interrupt. Am I going insane? I guess I am. So this is interesting. So here. Create arch them. Um, Wait, not create arch. Core arch ASM unsafe, sure. What is it? Yes, like that. Let's try that. This still crashes, huh? So insertion of those instructions fails. Missing. Avoid using named labels in inline assembly. Wait, ATT syntax. Because it is at least more consistent as an Intel one. I'm not sure if this is the one. Don't know where I am. 6 mode. Options ATT syntax, yeah. Two. So this does crash, which is interesting, but awful. Just exits. It goes triple page fault for some reason. I don't understand why. Why are you so problematic? If I instead write 0 here. Well, at least now I know that the problem is in the print again. So if I comment this out and put a 0 here, literally can't print again. Oh my god, why? Is it the same kind of problem? Why? Commenting out half of the functions does not help now. Wonder if I print like in hex instead of decimal it's gonna work. In pretty hex. What if I remove the format argument and just leave the string? Just literally print a len fails. Why? What if I change it to panic? Not create panic, just regular panic. Not panic. Whatever was it. Okay, so panic does work. Print does not. Why? What if I do print? And then panic? It survives. Okay, it's this again. So we change this to 0. It will work, or will it? It does, which is weird. Calling thing, I think doesn't work. Stack Overflow maybe? Perhaps. Bootstrap. Can I access? What? Now I'm gonna double this with regular bootstrap stack. Well, it might be Stack Overflowing, but probably no. Yeah. Even more doubling. I don't know why. Why? Why it's failing? Like, I can't even put anything in here. I mean, maybe I can put a loop. Panic doesn't work. It did fail again. Like, why? This is basically panic. But where I call it if I do this? Well, actually, maybe it does work and it's just with J axis again. If I do this. If I don't do this, will it run just fine? Hi. Any book on systems programming? I don't think I have. Like, I was, I don't even know. I don't even know where all my system programming background comes from. Like, I was, so I, back, a few years ago, like 6 years ago or something, or 5, actually more or less 5.5 years ago, I was interested in doing, I was interested in writing Hello World in like pure binary, and I was toying around with MU8086. I mean, I guess I am young. 16. Why did it take me so long to answer? Anyway, so yeah, I was dreaming about writing in pure binary when I was 11 years old. No, I was 10. I was 10 back there. Anyway, so yeah, I was dreaming about this. I found a random YouTube series about writing like a bootloader and stuff. So right now, best you can probably find. Oh, also there was a first words RAX. uh, Actually no, my first words were EAX because 64 wasn't. I didn't have 64 bits back then. See, if I... Oh, I'm not even signed in. What? I got kicked out of my account. Okay. Let me actually search YouTube for... Oh my god, I don't remember. Okay, hold on, let me log in and I'm gonna show you... Well, actually... Even if I log in, I can't really... I don't really remember it. So code... Anyway, x64 from scratch, maybe? So there was a great series of videos about... Yeah, this one's great. I'm pretty sure this is the one. Also, I don't know, I have this in my like watch later for forever. Oh, this is T2. I immediately recognized him with his face. Watch kernel developer do Linux kernel development. Let me check. I guess in my watch later. I mean, so I have my watch later, and then I have a few playlists saved just so I can watch them later. And like my actual watch later is not that much of watch later, but instead just videos I saved for later. So there's photolithography on silicon with PCB photoresist, growing colorful oxide layers on silicon, how to build two printers from scratch. Oh my god, wow. So those are all, I have watched them, but for some reason I have saved them. I wrote a Game Boy game in TypeScript, this is one that's cool. How to code a quantum computer. 8D audio. Okay, here are the ones I actually haven't watched. Advanced CPU designs 1. Architecture all access modern CPU architecture part 1. As I have watched, which is how LLM store facts by 3 Blue 1 Brown. Then we have making moddable games is quite easy. From I go by lots of names. This sounds familiar. How to fit an FPS into 96 kilobytes. I'm pretty sure I have watched it, but sure. Then I have also watched this one already. Let's build GPT from scratch, and Cliff Clicks, the sea of nodes, and the hotspot JIT, which is 6 videos in my watch later. The last one, by the way, is related to IRC of nodes, and I have no idea what it is, but this is some kind of IR, which will be used by some backends, compiler backends. Then I have 38, a playlist of 38 videos. Each one is pretty much 1 hour, which is a Minecraft Let's Play I want to rewatch again. I have then also Blinky to bootloader, bare metal programming, by low byte productions, which is 18 videos. Each one is pretty much 1 hour, which is so this one is good, I'm pretty sure. I have watched this, and the series might be good. So come on. Bootcode multi-boot header. Yeah, this sounds good. Well, you can. I guess you can just Google for good stuff. For just YouTube tutorials on how to do this. Also, Near Lichman, this is a great channel. Like, it's coming from another direction. And did my browser just hang? It did.
In this series, we'll create our own 64-bit operating system from scratch.
Stop.
Initially, we'll make an x86 compatible operating system, which is multi-boot 2 compliant,
Yeah.
but we may
yes.
expand this to other architectures and bootloaders in the future.
Come
This
on.
operating
Can
system
don't
is
stop
going
it.
to be primarily...
Okay, let's do this again. I don't remember. I think it was in C. Like, you can Google for Rust tutorials. For Rust, there is actually a great article. Hold on. Rust OS Dev. If you just Google Rust OS Dev, the first thing is probably this. Okay, the second thing is this one. This is a great one. This is a really great one. Satan was in C before, by the way, before I came in. So this is a great Rust article. It's using bootloader crate though, which is, well, I would not recommend using it. To me, it just doesn't feel good. Anyway, so there was a near Leechman. Sorry if I have misspelled the name. Frames again. No. No. Ah. Hold on. Regular procedure of switching from 5G to 2G networks. I don't know, for some reason. So Near Leachman, a really great YouTube channel. Oh, Lichtman, maybe actually. I don't know. Sorry if I mispronounced your name. Especially like.
Okay, so to build a simple distro,
So I
we're gonna
found
need
him
3 parts.
because of this video. Because he literally just compiles Linux kernel. I don't know, compiles BusyBox, writes a tiny init system, and just packs it all into an ISO and runs it with QEMU, and it works. Which is like why I got pulled in. So just a channel, and you can probably find. So for example, I think this is his last video. Smallest possible Linux distro. Yeah. X64, which by the way includes Lua. Out of all the things, he decided to put Lua on there. But sure. I mean, this makes sense. This makes total sense, actually. So yeah. How Linux boots, etc. There was also a series of videos on... what was it? Risk 5 OS diving source dive. This was also a great series of videos. Yeah, by Low Byte Productions, by the way.
Hello.
I'm pretty sure that's how I found them. So there should be a playlist. Series playlist empty. Why? No idea. Maybe he deleted the playlist. X-Point Math, yeah. I'm pretty sure I'm subscribed, I'm just not logged in. So yeah, source dive.
Hello.
I'm just gonna put it in. Then also, yeah, I mentioned this one already, which sounds interesting, but I haven't watched it. So that's all regarding systems and system development. By the way, 48%. I don't know if you can see it. 48. Well, you probably can't see it. Actually, it probably will be better if I open it this way. Focus. 48, 0.48, which is 48% of charge on here. Trying to discharge it completely. Okay, so yeah. OSDev Wiki, by the way, this is like the best by far source of operating system information. And it, of course, it doesn't load for some reason. Again, my internet problems. Hopefully frames are not dropping. So yeah, I guess that's it. So like, yeah, again, M8086 on Windows, I was back then writing some assembly stuff. I guess I just tried some bootloaders. I don't know. Because, yeah, before the serious things first were including multi-boot too. So I suggest just Google, like, research in YouTube. Oh my god, I can't spell. Writing an x86 bootloader. And then just going with the first one, with the first video. Near Lichtman or Lichtman, not sure. But exactly, like you've got a bootloader here in 6 minutes.
Let's go ahead and build a little bootloader. So for this I'm going to use NASM, the NASM assembler. And
Yeah, his videos are quick and dense. Pretty dense, yeah. So
and
it might be hard.
x86 assembly. So let's go ahead and start with the bits command. And this is 16 because we are running in real mode, so everything is going to be 16-bit.
Before like actually
afterwards, I'm going to
kernel, if you want to make a kernel, the bootloader. I remember I wrote like a kernel in a boot sector. Well, not a kernel, but like a command interpreter. Yeah, this was fun. Also, I think there was a series, an old series of videos of a guy writing an OS in Pascal. This was fun though, but I don't think I can find it anymore. It was weird but fun. Anyway, we'll solve this. How did I test what? Satan? The kernel I'm writing right now? QEMU? Kernel in the boot sector? Well, back then I was writing it in M8086, so this is a simple... if you're running Windows, this is a simple program to just emulate, I don't know, x86 or 886, I guess. It's probably not a website. Softonic. Well, yeah, I guess you can Google it. So yeah, I was starting with this again. M8086. So it's like a tiny program. You can Google where to find it. It's like a tiny program where you write assembly, and there were a ton of examples. And I did write a tiny command interpreter in a boot sector. I wouldn't call it a kernel because it doesn't actually do any kernel stuff. But yeah, I was using M8086. Then QEMU is like if you are actually writing a kernel. If you're going out of a boot sector, then you probably need something more powerful, which is NASM and QEMU, for example, or whatever. I have a Rust compiler which has a built-in assembler, and QEMU again. The Siri, there's no Siri, there's only. I mean, actually, I guess this is kinda right. I mean, it all started with me like just well, obviously not in English because I didn't know English back then. Custom in order to use it. Holy C. Anyway, actually, I don't know if Holy C compiles on other OSs. Yeah, I liked YouTube, and back then I didn't know English, so it was like, how does a computer work? This was like back in 2017, I'm pretty sure. I have started, well no, it was before. It was much before. Well, obviously it wasn't in English. But I was like, first video and just watch that, how CPU memory interacts and stuff. And then like operating system and just yeah. I imagine the operating system as like a piece of software that runs on a computer and allows you to run other programs. And it's less like I imagine that part of an operating system is just a start menu. But no, that's not true. That's kinda not true. I mean, it's kinda is, because desktop environment is a part of operating system. It's not a part of a kernel. Anyways, then I learned, I don't know where. I'm pretty sure YouTube videos or I don't know, Wikipedia, which said like an operating system consists of a kernel and a user space, whatever, and that's how that's how it went. And now here I am. I'm actually writing this kernel because one day in this summer, oh yeah, I'm pretty sure I haven't read any books actually. So yeah, a little bit of context, I guess, or a story. Ropless and okay, so yeah, why I'm writing this? In the summer, I was writing my compiler, which, yeah, yes, that's right. So yeah, I was writing my compiler in the summer, and then I raided Freedom Forge Studios, where there was Jax, and I said like, okay, so what did you do before you raid? Like, what did you do on your stream? I said I was writing a compiler, and Jax was like, okay, no, Jax was in his chat, was like, okay, that is interesting. DM me, and yeah, he told me about his kernel, and that's what I'm doing right now. Just a person. Well, should probably. I should probably be mentioning Texelware. So he made this after we met. He made this thing, home Texelware, an open source software organization. Wait, I'm focused on the thing. GitHub. Yeah, you can see Satan in GitHub again. My fork is more up to date. Projects. That's just a website. That's just his website. Basically. So if okay, so best way to tell who this is if I just open an organization and go to Rare, which is his game engine. He's from India, and why it doesn't show contributors? Well, anyway, last commit 10 months ago. What? So yeah, here he is. Easy enough. Anyway, yeah, it should be ending right now. But I don't know why it fails. Why it panics. Like, why? This line. Oh, it's not this line anymore, huh? It's not working. So if I comment this out, will it work? I don't even know why it can be this. No. So like, just a loop works. Commenting stuff out? Nope. Maybe, you know what? Maybe that's because I'm returning or something. No, I'm not returning. There's a loop. Literally loop which wastes CPU cycles. Huh? Okay, so for some reason, if I comment out the add zones part, Wait, no. The allocator part. Weird. So if I create a page allocator, well, nothing happens, I guess. But if I add a zone to it, I'm pretty sure it's just gonna optimize it all out. Then it crashes. Short physical, 16,000 zone, debug asserts. Self zones right, push. If I comment this out, will it, and it's replaced by, I don't know, print. Start size, Kavin live. Yeah, I did not mention that. I think I noted it, but didn't even think about it. Okay, so yes, pushing failed. Might be heap not being big enough. So this was what? 4 regions. So heap is in mod rs. I can do 16 here. Wait, 16 hex. Hold on, what am I doing? I can add another 0. Come on. Still doesn't work, so this is probably not the allocator problem. If I limit it to one zone, is anything gonna change? No. So adding a zone fails for some reason, which means initializing a binary body. Oh, that's atomics. Yeah, back to the atomics. Back to atomics. So if I actually just comment out atomics, will it work? I mean, I do need to kinda get rid of that. Get rid of that. And get rid of that. I don't know why, but I'm pretty sure that's what messes it up. Huh? What? Unknown field? Oh, there, it's accumulator. Should I instead fork it and fork the lazy, or not lazy, just binary body that's lockless? Okay, so it fails again for some reason. But it's not atomic. It's not because atomic. Clear allocator error. If I mean, I can't really get rid of body. I guess I can. Just literally comment all out, everything out. Empty all the functions. Still, why? Now, this time, why? We undo all of this. Okay, here, start size. Will it even print? If I do panic here. Okay, so it's all because of initialization, and it's not create panic, it's regular panic. By the way, the Gleam developer's life. Also Nigel. You should have mentioned that if you're mentioning Kavina life. Okay, so for some reason, is it constructing the zone or adding a zone? Oh, right. Well, whatever. That Zone of underscore. Type must be known at this point. What do you mean? What does it take? Page size 496. Oh, this. CPU. Pirate software. This guy's lying. Okay, stop. I don't know. I don't even know who this was, and I don't know who this is. I know who Pirate Software is, kinda, I guess. I don't know who this is. CPU ID. Jeez. Oh my god. How do I test this? Okay, maybe let's debug and do a breakpoint. Oh, maybe I did. I don't remember. Come on, all my rates were like 2 weeks ago. Let's see. Paging. So we have. Oh, it's no, it's memory pre-allocated on body. What do we have here? Add zone. Let's just breakpoint here and continue, and it's gonna break probably. It did break. I don't know why. I can't even debug the thing. Invalid read address if I put a breakpoint. Reason rejected. Probably because I should break on bootstrap. Debug. Break on Satan. x86. Kernel main, isn't it? Wait, it's normal angle. x86. Modern key setup is called. And will it break? Okay, it did break. Then let's list file. I'm pretty sure it's this. No debugging sim. Okay, I see what debug meant now. Let me go to linker script and bring debug back. So I probably don't need to load debug sections. I don't know about GOT though. Debug. Okay, now I can do break on the SRC. Where is it? Memory page allocators on body RS line 58. Let's do continue. Okay, didn't get there. Let's do line 47. I don't know. I don't know. Let's break on key setup actually. And continue, and will you? Okay, you did catch it. Finally. Now let's go to line 56, continue. We didn't get to line 56, what? That is interesting. Break on key setup. Continue. Break on line 55, continue. What? Okay, so we get out of bootloader. What happens? Why is it all messed up? 53. Line 55. Choose interrupt setup. He did not go get there. I don't know why. Run. No. Break on. Okay, let's actually. Let me list. And let me step. How do I step out? Finish. What? Hold on. I see why now. I guess. Create print line MBI PTR clone hash X. By the way, Foss Unleashed got fire. I'm not sure if he knows how to use it, but yeah, no fire stuff I can also. Pretty sure, yeah, I can. Okay, and just actually need to place this by painting. Ooh. Rust punches the yeah. How funny is it? 100380. 100380. Okay, so is this where I am not expecting this to be? Not where I am expecting it to be. MBI pointer. Maybe I actually messed it up. You know. How I messed it up? Punch what? Punch what? You can punch my plushie. You want. Lunar Vim. Oh, I remember I used it. Control G. Okay, so it says this number. Rust is like out. So this number is it? It's not. Rust is always with us, eh? Now it's gone. Well, you can't punch your own plushes either way. So let's hold 400. So 1k. 104, almost. So a little bit out of 1 megabyte. Which is interesting. So MBI pointer, which is a physical address at here. This is a little bit higher than 1 megabyte, which should be mapped in theory, but this is after the kernel, which is interesting. Because I don't think this was before. This was the case before. Have I messed up somehow? Push and yeah, fix up stack. And it should be fine. Where's the stack? In stack section. Makes sense. And the stack section is here, okay. So it is. So I am what? Map the first page table. Check bootstrap fits. Okay, so it does fit. And address is this for. So first megabyte is mapped as read write. Next, I map the rest as read only. I don't know why it doesn't work again. Like, hold on, what? Why are we panicking like here? I can't get out of boot info. I don't know, what can I see here? Size. Can do size. Total size. $1072. Okay, that's a lot. Which is, it doesn't explain why it doesn't work. Like if I try to debug it and then put a breakpoint somewhere on setup, continue list. So how do I step over next? Like after this line it fails. Like I can't debug. Why? How do I loop for like loop for a long time? Core arch nope. Unsafe. So we're gonna do no operation this amount of times. Q. Yes. Run. U64. Oh wait. Should be U64 here. Fails. Should be ending. I actually like the theme. This is one of my favorites for today. Probably my favorite today. Anyway, 63. It is. Reminds me of the theme Davninia was redeeming. Okay, so why are you not noping? I am pretty sure this should take a while, no? Like, why? Or... No, sleep won't work. I need to pause. No, I didn't. Sorry, but I did not. Yes, I did not know about that. Human uses one dark, interesting. Okay, so apparently parsing boot info is a problem. Because I'm pretty sure if I remove it here and like go remove it here, And yeah, I'm not using it here anymore. Maybe it's gonna run. Oh. Where's the motor key setup? Let me remove the delay. So now boot info is gonna be optimized by the compiler, optimized out, and it's gonna run. No, it's not. It's gonna run. Sad. Wait, no, I can load boot info. Wow. Like, I don't know. I can load it. I can't really use it. I mean, I can use it, but if that's weird. That's weird. Like, it fails on boot info loading stage. For whatever reason. Misstep. Okay, hold on. Let me remove the delay. Wait, not run. Debug. Recon key setup. Continue. Step. Okay. Pointer cast. Step. Finish. Where am I? Finish. Cannot access memory address list. Where am I? Finish. Is it whatever is it? No null. Huh? Okay, so it's set cannot access memory at address 4279D0 whatever. By the way, 30%, report 29, 28. So the battery is running low because this is like what, 3.3 volts maybe on a LiPo cell. This is pretty insane. I should not discharge it too much, but I have protection here, so it's fine. Should be fine. Okay, so why is it failing on where? No null? Like, and this process exited normally, especially weird. What is it? D, general protection violation. So page fault, general protection violation. I don't know why. I quit. Okay, I actually quit. We'll figure it out later. Where is the raid button? I wanna end this. Please end my sufferings. Like, why? What's this learning Lisp? Okay. Following. Read FOSS. Okay, sure. Let me see who else is here. Okay, for my following is deploying Gleam to Linux, which is cool. FOSS is learning Lisp. Okay, read FOSS, sure. Oh my god. Hold on.
Okay, the evaluation rule for all function call forms is simple, evaluating the remaining elements of the list as a list form and pass the resulting values within the function.
Okay, anyway. So yeah, I guess. Thank you for joining. I'm gonna click the rate button.
Okay, right, we noticed that. Hey, Infinite Coder.
Wow.
Are you done streaming?
Siri has.
The more complex expression.
I did not know Siri has an end stream thingy.
Special
That's cool.
upgrades.
Thank you, Siri. Okay, so yes, thank you for joining, guys. I will see you next time, which is hopefully not gonna be in 2 weeks, but more like this Wednesday.
Not all operations can be defined as
Bye.
functions because all the
Goodbye.
arguments to a function are
Bye.
evaluated before
Bye.
the function is called. Right.
And